This is the T90A main battle tank of the Russian army. It is the successor of the standard T90 tank, which was designed to replace the T-72 and the T-80 tanks. Designed in the 90s, this tank is still one of the most feared main battle tanks in the world. What you are looking at is the famous autoloader mechanism used in the T-72 and the T-90 tanks, where the ammunitions are stored and loaded quickly and automatically. In this video, with the help of 3D animation, we'll take a look at how the T90A tank works in detail. First, we'll look at how the tank's armored chassis and the complete track system works, and how the engine powers the tank and its equipment. Then we'll see how it protects itself with the help of active and passive protection systems, such as the Snorkel system, along with its laser warning systems, smoke grenade launchers, and the explosive reactive armor. Then we'll look at how the tank's anti-aircraft gun and the coaxial machine gun works and helps in keeping the enemies away. We'll see how the commander and the gunner use different types of sights, like the rangefinders, periscopes, thermal sights, and the night vision sights to identify and locate the targets. And finally, we'll take a closer look at the autoloader mechanism, where we'll learn about the different types of ammunitions used against a tank and how they are stored, loaded, and fired from a tank. This is going to be a detailed video, so sit back and enjoy. The T90A entered service in 2005 with the Russian army. It weighs around 46.5 tons, it's 9.5 meters long, 3.78 meters wide, and 2.19 meters tall. It has max speed of 37.28 miles per hour and max range of 310 miles. 3 crew members, the driver, the commander, and the gunner, are required to operate this tank. The tank has 2 main parts: the chassis and the turret. The body of the chassis is made of armor-grade steel and composite materials to withstand enemy fire. 6 highly elastic steel rods known as torsion bars are attached to the chassis. These bars resist twisting along their axis, and they act like springs for the vehicle's suspension. 3 hydraulic shock absorbers are attached to the chassis, right next to the 1st, 2nd, and the 6th torsion bar assembly. They are used to reduce vibrations and to absorb and dissipate kinetic energy. 6 shafts are connected to the torsion bar assembly, and 3 of them are connected to the shock absorbers as well. 6 unpowered wheels, known as road wheels, are attached to the shafts. The forwardmost wheel is known as the idler wheel. It's used to create tension to the track chain by applying pressure to the track links. The rearmost wheel is called a drive sprocket. This is the only powered wheel. It is connected to the transmission shaft, and it's used to move the track links. 3 small wheels called return rollers are fixed to the chassis. They keep the tracks running straight from the drive sprocket to the idler wheel. The track links, commonly known as caterpillar tracks, runs around all the wheels to form a continuous chain. They are usually made of steel to withstand difficult terrain and heavy loads. They are held together with 2 pins, and hence they are also called double pin tracks. 3 track link connectors, one on either side of the links and one in between the links, hold the links and the pins together. The pins allow the track links to rotate, making it easier for them to form a continuous chain. A center guide is fixed to the middle connector with a nut. They go in between the wheels to prevent the wheels from moving sideways. The forward section of the tank consists of a glacis plate, headlights, convoy marker lights, and an outrigger. The outrigger is placed below the glacis plate. It's used to clear out abrasive rocks, frozen soil, and to dig trenches quickly, and it acts like an armor when it's not deployed. The glacis plate is a sloped armor plate placed at the forwardmost hull of the tank. It is placed at an angle, usually around 30 to 40 degrees. When an armor-piercing sabot round hits the glacis plate, it bounces off of it. This is called ricochet. On the glacis plate, you can see few box-like structures. These are the Russian Contact 5 explosive reactive armor. In short, ERA. When shaped charged projectiles like the American Hellfire missile is fired at the tank, the reactive armor explodes and stops severe damage to the tank. These ERA comes in different sizes and shapes and are used all over the tank. We'll look at them later. On the Glacis plate, you can find two towing rope holders. On the right, there's a blackout light. It emits dim light at night and is used during night convoys to avoid being detected by the enemies. On the left, there's an infrared headlight. It is also used at night, and it emits a dim red light. 4 convoy marker lights, 2 facing forward and 2 facing sideways, are placed behind the headlights. They emit different colored lights at night and are used to tell the position of the tank at night. In the middle of the Glacis plate, there's a driver's periscope. This is the TNPO 68V driver's periscope. With the help of the periscope, the driver can see what's in front of him without having to put his head out of the vehicle. Behind that, you can see the driver's hatch. The driver enters the vehicle here. The rear section of the tank is for the engine and the transmission section. The T90A uses the powerful V92S2 diesel engine. This is a 4-stroke, 12-cylinder, water-cooled, turbocharged engine. Weighing 2,315 pounds, it can produce 1,000 horsepower with 3,922 Newton-meters of torque at 1,400 revolutions per minute. It comes with a preheater and air conditioning system for use in adverse weather conditions. It also has 2-stage cleaning system and a reduction gearbox with 7 forward gears and 1 reverse gear. The engine can be easily accessed for maintenance purposes. Behind the engine section, there's the radiator section. It draws in air to keep the engine cool. 2 towing rope holders are present in the rear end of the tank, along with an unditching beam. It is just a log of wood. When the tank gets stuck in muddy terrain, this beam is used to help get out of that situation. 2 external fuel drums, capable of carrying 72.6 gallons of fuel, gives an additional 124-mile range to the tank. Side skirts are fixed on either side of the tank's chassis. If mud and other debris are stuck to the tracks, the side skirts will allow them to escape easily, and they also provide some protection from enemy fire. 3 Contact 5 ERAs, in the form of plates, are fixed on either side of the tank for additional protection. The engine's exhaust port is placed on the left side skirts. 2 convoy marker lights, facing backwards, are also provided. Few containers are placed on either side of the tank side skirts. 5 containers, placed on the left side skirts, are called tool stowage panniers. Tools for the tank's repair and maintenance are stored here. The containers on the right side skirts are external fuel cells. The total fuel capacity of the tank, excluding the rear fuel drums, is 422.6 gallons.
If you are enjoying this video, subscribe to SYG Design Works for more advanced animations, and click on the bell icon to get notified when we upload a new video.
The turret is the brain of the tank. This is where the commander, the gunner, and all the necessary electronics are present to detect and attack the target. With the help of an electric motor and an amplitude, the turret can rotate 360 degrees in just 9 seconds, which is 40 degrees per second. The older T90 tank had a cast turret, whereas the T90A has a welded turret. Compared to cast turrets, welded turrets are light in weight and cost-effective, but are labor-intensive to mass-produce. The T90A's main gun is the 2A46M smoothbore gun that fires 125mm ammunitions. The part to which the gun is fixed is called a mantlet. If you look at the T90A from the front, it looks like it has 2 red eyes. This is the famous Stora 1 electro-optical active protection system. The Stora system consists of 3 main parts: the dazzlers, the laser warning sensors, and the smoke grenade launchers. 2 dazzlers are fixed on the turret cheeks on either side of the main gun, facing forward. A high-precision laser sensor is mounted on the turret, and it covers the 90 degrees arc in front of the tank. 2 low-precision laser sensors, one facing the left side of the tank and the other facing the right side, are also mounted on the turret. 6 smoke grenade launchers are placed on the left, and 6 are placed on the right side of the turret cheeks as well. The Stora dazzlers are mainly used to disrupt enemy laser designators and laser rangefinders of incoming anti-tank guided missiles. The dazzlers continuously emit coded pulsed infrared jamming signals. When a laser beam riding missile, such as the TOW missile, is fired at the tank, the infrared dazzlers disrupt the missile's guidance system, which makes the missile lose its sense of direction. The laser warning sensors will detect enemy laser designators whenever the tank is targeted, and the smoke grenades, also known as the aerosol screen laying system, are immediately deployed. These are the 3D-17 smoke grenades. When they explode, they create a thick smoke screen around the tank, making it difficult to target the tank. Now the tank can quickly and safely move to a safer position. The laser sensors are designed to turn the turret automatically towards the enemy when it detects threat. The Stora system can operate continuously for 6 hours, but the downside is that it is not effective against modern laser-guided missiles. 8 contact 5 ERAs are fixed to the turret cheeks, in which 2 are facing forward and 3 on either side of the tank are facing sideways. The Stora system's power relay boxes are placed on the ERAs on either side of the tank. The topmost part of the turret is the least protected and the most vulnerable part of the tank. American missiles such as the Javelin missiles are designed to attack the tank from the top. To protect the tank from such attacks, multiple contact 5 ERAs are fixed on top of the turret. They look like bricks and are therefore called ERA bricks. The wind sensor on the turret will measure the wind speed and direction and feeds that information to the ballistic computer to calculate accurate trajectory for the projectiles. A convoy marker light facing backwards and a tactical number display light are fixed to the wind sensor. An antenna is provided to communicate with other tanks. 3 huge storage boxes, one on the left, one on the right, and one in the center of the turret face are provided. A snorkel is also provided for deep water wading. When the tank moves a few meters deep underwater, the snorkel extends out of the water and provides continuous supply of oxygen to the tank crew. These are the hatches for the commander and the gunner to enter the vehicle. This entire section is called Commander's Cupola, and it can be rotated. This is the 6P49 Cord anti-aircraft machine gun. Next to it is the ammo storage box. These are the 12.7mm rounds. The commander controls the anti-aircraft gun without getting out of the tank. Weighing 60 pounds, this gas-operated, belt-fed anti-aircraft machine gun is capable of firing 750 rounds per minute. It does not have a trigger. Instead, it has a solenoid, which is a type of electronic trigger that the commander uses to fire the weapon. To look at the aerial target, the commander uses the PZU-7 anti-aircraft sight mounted right next to the machine gun mount. This sight, like the Periscopes, is made of mirrors placed at 45 degrees angle, and it helps the commander to see the aerial target safely from inside the vehicle. Below the anti-aircraft gun, there's the commander's sight. This is the TCAN-4S commander's sight that can be used in daylight conditions as well as in night vision mode. With 8 times magnification and vertical plane stabilization, it can identify targets that are 800 meters away from the tank. It can also see aerial targets to some extent. The commander uses this sight, along with the fire data generated by the ballistic computer, to guide the gunner in order to accurately aim at the target. On the commander's hatch, there are 2 periscopes. These are the TNPO 160 Commander's periscopes. With the help of rotating cupola, they provide 360 degrees view from inside the tank. Weighing only 7.5 pounds, they provide 78 degrees horizontal and 28 degrees vertical plane of view. Right next to the main gun, there's the coaxial machine gun. This is the PKT machine gun, which is operated by the gunner. It fires 7.62mm rounds, with a rate of fire of 800 rounds per minute. It weighs around 20 pounds, and it's used against light targets such as the infantry, light armored vehicles, and other close-range threats. Like the anti-aircraft gun, it also has a solenoid trigger. In front of the gunner's hatch, there's a laser rangefinder. This is the 1G46 laser rangefinder. It's used to detect tank-sized targets, and it also has a missile guidance channel. It helps the gunner to accurately measure the distance to the targets that are around 5 miles away from the tank. They have 2-axis stabilization and can be used in daylight conditions only. Next to it, there's the ESSA thermal imaging sight. The ESSA is an upgraded thermal sight from the Buran M sight that were used in the older T90 tanks. It can be used as a daylight sight and a night vision sight as well. It allows accurate firing to a range of 5 miles in daylight conditions and 2 miles in night vision mode. It is designed to work with the laser rangefinder, and together, they make this tank a deadly battle machine. An infrared searchlight is also provided for the gunner to look out for threats at night. 2 periscopes, one on the gunner's hatch, facing forward, and one facing the left side of the tank, are also provided to the gunner. Between the hatches, there's a small port. This is the stub casing ejector port. The unused rear end of the ammunition, called stub casing, is ejected out of the vehicle from here. Finally, we'll take a look at the autoloader mechanism. This entire section is called the autoloader section. It consists of 4 main parts: the breech, the stub casing ejector, the ammunition cassette, and the cassette hoist assembly. The breech is where the ammunition is placed and fired from. This breech has 3 hydraulic cylinders, 2 placed diagonally and 1 below the gun axis. When it fires a round, the hydraulic cylinders move back, absorbing the shock and dampening the recoil force. The commander and the gunner's seats are placed above the ammunition cassette. This is where the ammunitions are stored. The cassette is rotated after a round is fired to select a new round. The top section is where the propellant charges are stored, and the bottom section is where different types of anti-tank rounds are stored. This is the ZH-40 propellant charge, commonly used in Russian tanks to propel the projectile forward. It is filled with straw-shaped nitrogen pyroxylin gunpowder. The outer casing is combustible. The only part that remains after firing a round is the lower casing, called stub casing. This casing is later ejected out of the tank. The 3 most commonly used anti-tank rounds are the high-explosive fragmentation rounds, high-explosive anti-tank rounds, and the APFSDS rounds. This is the BM9 armor-piercing, fin-stabilized, discarding sabot round, commonly known as APFSDS round, or a long dart penetrator round. It consists of combustible outer casing, propellant charge, sabot with a ring, and the penetrating dart. Inside this dart, there's the penetrator core. When the APFSDS round is fired, the outer casing is burned away. The sabot consists of 3 heavy metal pieces that are used to hold the penetrating dart. Once the round leaves the tank gun, the steel ring that is holding the sabot gets detached, and the sabot is discarded, and hence the name, discarding sabot. The penetrating dart core is usually made of depleted uranium or tungsten, but this one is made of steel. The high-explosive anti-tank round, commonly known as heat round, consists of a copper cone surrounded by explosive charge. When the round hits the tank, the explosive is set off, which collapses the copper cone into a high-velocity shaped charge jet. This jet is capable of penetrating heavy tank armor. The high-explosive fragmentation round consists of explosive charge placed inside a metal body. When exploded, the outer casing breaks into tiny pieces or fragments that are capable of seriously damaging armored and unarmored vehicles, as well as fortifications and enemy manpower. In our upcoming videos, we'll take a deeper look at these ammunitions. On top of the ammunition cassette, there is the cassette hoist assembly. It consists of a cassette hoist. It lifts a single unit of the ammunition cassette that holds the charge and the projectile together and aligns it with the breech. On top of the hoist assembly, there is a rammer. The rammer is a flexible metal chain that will push the charge and the projectile into the breech. First, the projectile is placed inside the breech. Then the charge is aligned and placed behind the projectile. The cassette hoist returns to its position before the firing begins. Let's look at it in action. The round is fired, and the stub casing comes out of the breech and is caught by the stub casing ejector. Finally, the ejector rotates and aims towards the ejector port. The ejector port door opens, and the stub casing is ejected out of the tank. Let's look at the entire mechanism in action. One more time from another angle. Capable of firing 7 rounds per minute, the T90A's strong frontal armor and low profile makes it an excellent choice for flanking and sniping enemy tanks. Many countries around the world are using the T90A and other variants of the T90A, and it is still one of the most feared deadly battle tanks in the world. And that is how the T90A tank works. Thank you for watching.